Hello everyone, welcome to my class. In today's class I am going to cover trigonometry and the Cartesian coordinate planes. So let me start the class right away. First, quick recall. A Cartesian coordinate plane is a plane in two dimensions, or in r square, that means r cross r, that means we are intersecting two real lines orthogonally, formed by the intersection of two perpendicular lines. One is a vertical line called the y-axis and another is a horizontal line called the x-axis, and they intersect at a zero called the origin. So let me talk about this diagram here. This is y-axis, this is x-axis. They intersect at origin. They make an angle here 90 degrees. By the way, this x-axis is also a real line, y-axis is also a real line, so we can denote this by r square also. Awesome. So now in these sections we will define 6 trigonometric functions using these Cartesian coordinate planes. Remember, in earlier sections we defined those trigonometric functions using unit circle. Awesome. Next, definitions. Let P be any point on the terminal side of an angle theta in standard positions. So that means P is a point in the plane which corresponds to the angle theta at the origin. Then this distance here, OP distance, is simply under the radical x square plus y square. Then from point P, draw the perpendicular on x-axis, then this is y and this distance is x. Then using this right triangle formed in the standard position, we can define our 6 trigonometric functions. So the sine function is defined as perpendicular over hypotenuse. Here perpendicular is y, hypotenuse is r, so y over r. Similarly, cosine function is defined. So cosine theta equals to base over hypotenuse. Base is x, hypotenuse is r. So cosine theta equals to x over r. Similarly, tan theta equals to perpendicular over base, y over x. Similarly, the cosecant function is the reciprocal of sine functions. Secant function is the reciprocal of cosine functions. And cotangent function is the reciprocal of tangent functions. So now we define our 6 trigonometric functions using coordinate planes. I hope this makes sense to you all. Now let's move on. Note, for quadrantal angles, that means the angles along the x-axis and y-axis, so those angles are 0 degree, pi half, pi, or 3 pi over 2, or 2 pi, etc. The r means the hypotenuse of that corresponding right triangle is always 1. So that means this r always turns out to be 1. Great. So now let's move on. Great. Let's move on. Evaluating the trig functions given a point. So the idea is, plot the point, draw a triangle on x-axis, find the missing side, write the trigonometric functions using x, y, and r. Awesome. So let's do a quick example. Example 1. Let theta be angle in standard position whose terminal side contains the point P with the coordinate -6, 8. That's better. Find all 6 trigonometric functions of theta. So here, the given point is P, which lies in the second quadrant. This is -6 is this distance, +8 is this distance. Then let's find this distance of point P from the origin, which is r. Here, r equals to, under the radical, on first coordinate is square plus second coordinate is square. I'm talking the coordinate of point P. So minus 6 square is 36, 80 square is 64, 36 plus 64 is 100. So radical 100 is 10. So we found r is 10. So what do we have here so far? We have x equals to negative 6, x and y is positive 8, and we just found r is 10. Then we have the formula here. Using those formula, now let's find the 6 trigonometric functions here. So sine theta equals to y over r, 8 over 10. Cosine theta is x over r, minus 6 over 10. And tan theta equals to y over x, that is minus 8 over 6. Similarly, we can define cosecant theta, secant theta, and cotangent theta, because these are the reciprocal of sine, cosine, and tan. I hope this makes sense to you all. Now let's move on. Next, evaluating the trig functions given an angle theta. So the idea is draw an angle in standard positions and find the reference angle theta r, and then use the formula. So example 2, find the exact value of sine, cosine, and tangent at a given angle using reference angle. So given angle is part A, theta equals to 210 degree, and part B, theta equals to 600 degree. Begin the solutions. Part A. Solutions. Part A, here the terminal side of the angle 210 degree lies in third quadrant, where both x and y are negative. So here the reference angle, then theta r equals to 210 degree minus the pi means 180 degree, which turns out to be 30 degree. So then instead of computing sine 210, now we compute sine 30 degree, but keep in mind we are in third quadrant, sine will be negative. So here sine 30 degree equals to then negative 1/2 in third quadrant. I hope this idea makes sense to you all. Similarly, cosine 30 degree is negative radical 3 over 2, and tan 30 degree equals to sine 30 degree over cosine 30 degree. So divide this number by this number, turns out to be 1 over radical 3, and keep in mind the tangent function is positive in third quadrant, so the result turns out to be positive. I hope this idea makes sense to you all. Now similarly, part B, here given angle is 600 degree. So 600 minus this is 2 pi, 360 degree, it gives us 240 degree, and 240 degree, the terminal side of 240 degree lies in third quadrant again, where again both x and y are negative. So the reference angle is 240 degree minus 180 degree, which turns out to be 60 degree. And keep in mind, in third quadrant, sine is negative, cosine is negative, only tangent is positive. So hence, instead of computing sine of 600, we are computing sine of 60 degree with negative sign. So sine 60 degree equals to radical 3 over 2 minus, because 600 lies in third quadrant. Similarly, cosine 60 turns out to be negative 1/2, and tan 60 turns out to be radical 3. This is simply, I'm dividing this value by this value. I hope it makes sense to you all. Now let's move on. Example 3, find the values of x, y, and r from the given informations. So the given information is tan theta equals to negative 12 over 5, and cosine theta is positive. Write the values of all 6 trigonometric functions of theta. Great. So now let's begin the solutions. So here tan theta equals to negative 12 over 5 given to us. and the ratio of y and x is the tan theta. Then from here, x is 5 and y is negative 12, and given to us cosine theta is positive, that means x is positive, so that's why y is negative 12 here. Then the terminal side of the angle theta lies in fourth quadrant, because in fourth quadrant x is positive and y is negative. Next, let's find the value of r using the distance formula. So under the radical, x is square plus y is square, that is under the radical of 5 is square plus minus 12 is square. We know 5 is square is 25, 12 is square is 144. Then add 144 plus 25 gives us 169, and we know under the radical of 169 is simply 13. Great, so we have value of r, which is 13, we have value of x, which is 5, we have value of y, which is negative 12. Then using the formula, we can easily find the value of 6 trigonometric functions. So lastly, sin theta is y over r, that means negative 12 over 13. Cosine theta is x over r, so x is 5, r is 13. Now tan theta is y over x, that's the given to us, which is negative 12 over 5. And cosecant theta is the reciprocal of sin theta, which is minus 13 over 12. Secant theta is the reciprocal of cosine theta, so simply 13 over 5. And cotangent theta is the reciprocal of tan theta, so simply cotangent theta equals to minus 5 over 12. Great. I hope it makes sense to you all. Now let's move on. Example 4. Find two positive and two negative angles that are coterminal with 12 degree and negative 215 degree. Let's begin the solutions. So the coterminal angles are, we define as theta plus 360 degree times the integer. This integer can be negative or positive. So for theta equals 12 degree, so the coterminal angles are 12 degree plus 360 degree. I took k equals to 1 here, which turns out to be 372 degree. Or I can take k equals to 2, which gives me 12 degree plus 720 degree equals to 732 degree. So these are coterminal angles with 12 degree. Similarly, I can take k is negative 1 and find the angle negative 348 degree. Similarly, I can take k equals to negative 2 and find the coterminal angle negative 708 degree, and so on. If you pick k equals different value, then you will get different angles here, so the answer may vary. Similarly, part B, the coterminal angle for negative 215 degree is, again, let's put this formula here. Negative 215 degree plus 360 degree turns out to be 145 degree. Similarly, put k equals to negative 1 or positive 2 or negative 2, then it turns out that 505 degree, negative 575 degree, negative 935 degree. I hope these computations make sense to you all. Now we finish these problems, as well as we finish these sections, as well as we finish this chapter 5. Thank you.